Hi students, welcome to the next video. In this video we are going to discuss about short answer questions and multiple choice questions of third chapter acids, bases and salts. So in short answer questions, as you know, the short answer questions in the board examination will come for 2 marks. So in the first section these questions will be there. So 3 questions will be given. All the 3 questions you have to answer. So we'll discuss about short answer questions of third chapter acids, bases and salts. So the first question, all the questions will be displayed on the screen. Just first question I will read out. The first question is, what is the color of methyl orange indicator and phenolphthalein indicator? Okay, in acid medium. Okay, what is the color of methyl orange indicator? Color of methyl orange indicator. The methyl orange indicator turns into red color in acid medium. Okay. Sir, what is the color in basic medium? Methyl orange indicator turns yellow in basic medium. That is in basis. Next, what is the color of phenolphthalein indicator? In acid medium is colorless, whereas in basic medium is pink. But the question he asked is only acid medium, but I explained both. Methyl orange indicator in acid medium, red color. In basic medium, it shows yellow color. Phenolphthalein indicator in acidic medium, colorless. Colorless in which medium? Acid medium. Acidic medium. Okay, and phenolphthalein turns pink color in which medium? Basic medium. Very, very important question. Even you may get this one in bit part also. Okay, very, very important. Write the results of the experiment to observe the reaction of acids with the metals. The question is displayed on the screen. Write the results of the experiments when acids are reacted with the metals. For example, HCl, hydrochloric acid, dilute HCl, no aqueous. If reacts with metal like zinc, okay, gives rise to equation is ZnCl2 plus H2. You see the balancing. HCl, two molecules of HCl reacts with Zn, gives rise to ZnCl2. In aqueous form, hydrogen gas is liberated. So the results of the experiment, if acids are reacted with the metals, forms their respective metallic salts with the liberation of hydrogen gas. Now, if I talk about some other example, now take the example of H2SO4. When reacts with the zinc, gives rise to ZnSO4 plus H2. But if I compare the reactivity of these two, somewhat even in this reaction, sometimes the other gases also may be liberated, sulfur-based gases. But primarily we are talking about here is hydrogen. Okay, so if a metal reacts with the acid or acid reacts with respect to metal, liberates which gas? Results of the experiment is respective metallic salt here is zinc chloride, and what gas is liberated means hydrogen gas. That is a solution for the second question. Third question is how to test the gas evolved when acids reacts with the carbonates. Third question is how to test the gas when acids are reacted with the carbonates. For example, reaction of acid with the carbonates. I will give an example. Okay, the gas liberated is commonly carbon dioxide gas is liberated. The other products you will see based on the type of acid what we are taking, type of carbonate, which carbonate you are going to take. For example, HCl, hydrochloric acid, when reacts with the carbonate like sodium carbonate, Na2CO3, sodium carbonate, HCl, if both reacted together, 2HCl I am taking, gives rise to NaCl. That is, NaCl is one product, 2NaCl. And how many hydrogens are there here? 2 are there. So I am going to write H2. How many oxygens are there? 3 are there. I am going to write 1 oxygen here. And 1 carbon is left, 2 more oxygens is left. The gas liberated is carbon dioxide gas. So if acid reacts with carbonates, liberates hydrogen, carbon dioxide gas. Okay. So for example, I am writing complete equation by taking one example. Two molecules of HCl reacts with sodium carbonate salt, gives rise to sodium chloride salt, common salt, water and carbon dioxide gas. Now gas liberated is water, carbon dioxide gas. Sir, how to test this gas? So carbon dioxide gas can be tested in two different ways. One is take a few ml of lime water. Lime water means calcium oxide, quicklime. If combined, mixed with water, gives rise to calcium hydroxide, which is called slaked lime. Slaked lime. It is commonly called as lime water. Lime water. So this is, I am taking a few ml of lime water in the glass beaker. So the gas which was liberated in the given reaction, this carbon dioxide gas, if I pass this carbon dioxide gas into the lime water, this lime water turns into milky white. That is a test for carbon dioxide gas evolved. Okay, when acids are reacted with carbonates, carbon dioxide gas is evolved. How will you test the gas means? Pass the carbon dioxide gas into the lime water. The lime water. When you pass carbon dioxide gas into lime water, this is lime water. Lime water turns into milky white. Milky white precipitate is formed. Milky white precipitate is formed. That precipitate name is calcium carbonate is formed. Remember that. Okay. Next one is one more test is there for testing carbon dioxide gas. If you bring when the carbon dioxide gas is evolved, when the carbon dioxide gas is evolving, for example, in the test tube I have done this particular activity. Okay, reaction. The carbon dioxide gas is evolving. If you bring a burning matchstick, okay, if you keep the burning matchstick or a burning candle or a burning splinter in the presence of a carbon dioxide gas, it puts off. Puts off means carbon dioxide gas extinguishes the fire. Carbon dioxide gas will extinguish the fire. That is a one more test for carbon dioxide gas. Okay, I hope you understood this. Even I explained with the equation. The question is, if acids are reacted with the carbonates, carbon dioxide gas is evolved. How will you test that gas evolved? Means one is by passing the carbon dioxide gas in the lime water, it turns into milky white. One more way is measure the priority will be given to conversion of carbon dioxide lime water into milky white. And one more way is to test the gas is if you bring a burning splinter or a burning matchstick near the carbon dioxide gas, it puts off the flame, not with pop sound. If pop sound means that is hydrogen gas. Carbon dioxide gas never gives a pop sound if you keep a burning splinter. That is a third question. The fourth question is, what is the limit of the pH? Okay, which causes tooth decay. The pH of the pH value is less than 5.5. It causes a tooth decay. Sir, how we can able to control that tooth decay means you have to use the paste which is basic in nature. By using the paste which are basic in nature, we can able to control the tooth decay. Next one, write an example for the reaction of base with non-metallic oxide. Now the fifth question is, write an example. Write an example for reaction of base with a non-metal oxide. Reaction of base with non-metallic oxide. Okay. Now write an example for the reaction of a base with a non-metallic oxide. We know sodium hydroxide is a base and non-metallic oxide. For example, carbon dioxide is a non-metallic oxide. Carbon is a non-metal. If carbon is burnt in presence of oxygen gives rise to carbon dioxide. So carbon is a non-metal. If non-metal is burnt in presence of oxygen gives rise to non-metallic oxide. Now sodium hydroxide is basic in nature. We know that non-metallic oxides are acidic in nature. Non-metallic oxides are commonly they are acidic in nature. So if the sodium hydroxide, which is a base, when reacts with a non-metallic oxide like carbon dioxide, which is acidic in nature, I will write the equation here. NaOH plus CO2 gives rise to, and I will write 2 in front of this as a coefficient. 2 NaOH plus CO2 gives rise to Na2. 2 sodiums are there. I am writing Na2. 1 carbon is there, C. And we are having 2 plus 1. How many oxygens are there? Total oxygens are 2 plus 2, 4 are there. I am writing Na2CO3 plus H2O. That is salt and water. So, if bases are reacted with non-metallic oxides, what is formed? Salt and water. Here this is sodium hydroxide, carbon dioxide, gives rise to sodium carbonate and water. This is salt and water. This is also called as a neutralization reaction. It can be called as a neutralization reaction. If carbon dioxide gas is reacted with a base, gives rise to respect to carbonate salt and as well as a water. Here I have took the example, sodium hydroxide reacts with carbon dioxide, gives rise to sodium carbonate and water. It is a neutralization reaction. Now the sixth question is now the sixth question from Abhyasa Deepika. The question will be displayed on the screen. Why the bulb did not glow in glucose solution when electricity is passed through it? Why the bulb did not glow when the electricity is passed or current is passed into the glucose solution? Now, for example, why the bulb, the question is displayed on the screen. See, why the bulb did not glow when electricity is passed through glucose solution. I am taking one glass beaker. Okay, so in this I am going to take 2 graphite rods which are acting like electrodes and connect the ends of the graphite rods to one switch, and this switch is connected to the AC plug. AC plug is connected of capacity 230 volt and the ends are connected to the graphite rods. And before I switch on the circuit, okay, that is switch on the AC supply, pour few ml of glucose solution. So glucose chemical formula is C6H12O6. When combined with water gives rise to C6H12O6 aqueous. Okay, so now even you have to connect the bulb here actually. Now we have to connect the bulb here. When electricity is passed into the glucose solution, the bulb will not glow. The main reason is glucose. Okay, in glucose solution we have glucose in C6H12O6. The glucose which is aqueous form now, when you pass electricity, it does not dissociate into ions. It is not going to break down into H plus ions. Glucose will remain glucose only. Okay, no dissociation. No dissociation of glucose into ions. Which ions? H plus ions. Into H plus ions. So H plus ions are not produced. So hence the bulb will not glow. Understood? What is the meaning of dissociation or ionization? Dissociation is also called as ionization. Dissociate means breaking down. The process of breaking down of a given compound into corresponding ions is called ionization. So here when you pass electricity, okay, through the glucose solution, it is not going to split into respect to ions. Hence the bulb will not glow. Hence the bulb will not glow. Bulb not glows. The bulb will not glow because it is not going to split into respect to ions. Very, very important. Sir, if you take HCl, that is an aqueous form, if you pass electricity, so in that case the bulb will glow. Why, sir? And means that is because HCl is going to split into H plus and Cl minus ions. So H plus ions are produced, hence the bulb will glow. In case of HCl, bulb will glow. But in case of glucose, it will not glow because it is not dissociated into its corresponding ions, like H plus ions are not produced, hence the bulb will not glow. Remember that. Now the seventh question is, write the names of the two salts obtained from common salt. The two different salts obtained from common salt. Common salt chemical formula is NaCl. It is called common salt. It is also called as rock salt. Chemically it is called as sodium chloride. The two salts which are obtained from the common salt is, one is washing soda, you can write. Okay, washing soda, nothing but a Na2CO3 10H2O. So next one is baking soda, that is NaHCO3. Washing soda, chemical formula is Na2CO3 10H2O. It is chemically called as, commonly called as a washing soda, which is called sodium carbonate. Okay, 10 molecules of H2O means decahydrate. It is chemically called as sodium carbonate decahydrate. What is the meaning of that? Sodium carbonate means Na2CO3. Decahydrate means deca means 10. 10 molecules of water. Hydrated means water. So 10 molecules of water is present, hence sodium carbonate decahydrate is commonly called as washing soda. Washing soda is chemically called as sodium carbonate decahydrate. Some students used to write washing soda means Na2CO3. If you write like that, it is totally wrong. You should write Na2CO3 dot 10H2O. That is 10 molecules of water is present. Okay, which is water crystallization. Next one is baking soda, sodium bicarbonate. It is chemically called as sodium bicarbonate. One more is there, bleaching powder. Third one is bleaching powder, that is CaOCl, calcium hypochlorite. Okay, so this is called bleaching powder. Okay, next one is plaster of Paris, that is calcium sulfate hemihydrate. Okay, plaster of Paris, it is called calcium sulfate, chemically called as calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Very, very important. Okay, so these are the salts are obtained from sodium chloride common salt. The different type of chemicals are obtained from the common salt are, first one is washing soda, sodium carbonate decahydrate, baking soda, sodium bicarbonate, bleaching powder, calcium oxychloride or calcium hypochlorite. Next is plaster of Paris, calcium sulfate hemihydrate. Eighth question is, if the solution turns red litmus into blue, if the solution turns red litmus to blue, what will be the possible pH value of that solution? Okay, it is commonly greater than, pH value is greater than 7. Ninth question. Two solutions have their pH values as pH value of first solution is 13.5 was given and pH value of the second solution is 10.5. This is solution A, solution B. Which of them is a strong base and which is weak base? Okay, among these two, very strong base is the pH value is equal to 13.5. The first solution is a strong base. Means reason is the pH value from 11 to 14 are strong bases. If the pH value is greater than 7, the pH value is greater than 7 to below 11. Those are weak bases. So in these two solutions, first solution is having pH value 13.5, then it is a strong base. The pH value is equal to 10.5. It is a weak base. Remember this, very, very important. Understood. Now MCQs, we'll be discussing about MCQs. The first MCQ will be displayed on the screen. Check once. Which of the following turns blue litmus paper to red color? Which of the following turns blue litmus to red? The first option given is which turns blue to red color. Litmus is turned. Question is displayed on the screen. Which of the following turns blue litmus paper to red color? First option given is NaOH. Second option given on the screen is calcium hydroxide. C option given is H2SO4 and D option is KOH. Okay, so sodium hydroxide is a base. It never converts blue to red. It turns red litmus paper to blue color. Calcium hydroxide is also base. KOH, potassium hydroxide is also base. So among all these options, the right option is C, that is sulfuric acid, because it is an acid which turns blue litmus paper to which color? A red color. That is right option is C for the first multiple choice. Now the second multiple choice is even. I will write the second multiple choice answer here only. The value of pH is more than 7 in the following. The value of pH is more than 7 in the following is. Question is displayed on the screen. Just see the question. The value of pH is more than 7 in the following is. First option given is A is HCl given. B is H2SO4. And C is HNO3. And D is NaOH. So which of the following options having a pH value greater than 7? The right option for this particular question is D. Sodium hydroxide is a base. Bases are having pH values greater than 7. All acids, all these three are acids which are having pH value is less than 7. For the bases, the pH value will be greater than 7. So the right option is D for this particular question. Third question is non-metallic oxide. Non-metallic oxide plus dash gives rise to salt plus water. The question is displayed on the screen even. Non-metallic oxide plus dash gives rise to salt and water. Non-metallic oxides are acidic in nature. And salt and water, when does the salt and water is formed? In neutralization reaction. In neutralization reaction, acid reacts with the base. Now here non-metallic oxides are acidic in nature. Then if reacts with the bases forms salt and water. So in the given options, the right option is acid. First option is acid A. Second option is B, base. C is neutral solution. And D is none was given. So the right option is B for that. Okay, right option for the given question is B. I will explain one example. Non-metallic oxide, for example, carbon dioxide, reacts with a base like, take the example of sodium hydroxide, gives rise to Na2CO3, salt plus water. I will show you the balancing given. Carbon dioxide is a non-metallic oxide, reacts with the base like I am taking 2 molecules of sodium hydroxide, gives rise to, how many sodiums are there? 2. You got 2 sodiums. How many carbons are there? 1. You got 1 carbon. How many oxygens are there? 2 plus 2. 4 are there. Here you got 3 and 1 here. How many hydrogens are there? 2. You got 2 hydrogens. Is it clear? So this is a reaction. For example, explain with one equation. Question. Now the fourth multiple choice question is displayed on the screen. Just see once. Which of the following is used for making toys? The right option is, for fourth one, the right option is calcium sulfate hemihydrate. Option is A. Calcium sulfate hemihydrate. Nothing but CaSO4 dot half H2O. This is commonly called plaster of Paris. Chemically called calcium sulfate hemihydrate. Hemi means half. Hemi means half. Half molecules, hydrated means water, contains water. Half molecule of water is present. Hence calcium sulfate hemihydrate name. and common name is plaster of Paris. Plaster of Paris is used, okay, in making of toys and idols also. Fifth question is, when does the rain is treated as acid rain? If the pH value of the rainwater is less than 5.6, if the pH value of the rainwater is less than 5.6, less than 5.6, pH value is less than 5.6 means then it is considered as an acid rain. That rain is called as acid rain. The pH value of the rainwater is less than 7, it is called acid rain. Remember that. Sixth multiple choice is, in the activity removing water crystallization or heating copper sulfates crystals turns into, okay, in the activity removing water crystallization, the copper sulfate salt, copper sulfate with 5 molecules of water. Copper sulfate salt with 5 molecules of water is blue in color. After performing the activity, removing water crystallization. So, removing water of crystallization. Crystallization, this copper sulfate salt loses 5 molecules of water, CuSO4 plus 5H2O, and the blue color copper sulfate salt turns into white color. This is, if you remove the water molecules present in the copper sulfate salt, it is removing water crystallization. Before removing water crystallization, that is, color of the copper sulfate salt is blue color. After heating it, okay, it loses 5 molecules of water, then the color changes into white color. Okay, so with this the end of all short answer questions. All with this the end of all short answer and multiple choice questions of third chapter from Abhyasa Deepika. I hope you all understood. If you understand my explanation, please like, share and subscribe and even comment on the explanation. Thank you.